a lot of what I'll cover here, a lot of what I'll talk about in terms of developing quantitative reasoning in courses we teach comes out of a program called Niche, N-I-C-H-E. It's the numeracy infusion course for higher education. Was developed by, for those of you who may know her, Esther Wilder in Lehman, probably at this rate, maybe more than a decade ago. Fantastic course that I know quite a few John Jay faculty went through, and its purpose was to do really just what we're talking about now, right? How do we build quantitative reasoning skills into the courses that we teach? Certainly, for those of us who teach outside of the STEM fields, where QR tends to be more of a given. I'm going to, let's see, I'm going to share my screen with you all and go through at least some of this stuff quickly. I don't have to make it full screen. When it comes to quantitative reasoning, our curriculum, I know many of you already know that it's, we have QR in some places, not a lot. We have some quantitative reasoning that's required as part of our Gen Ed curriculum, but it's certainly it is not consistently delivered outside of the 9 credits of the Gen Ed that are devoted to quantitative reasoning ideas. I bring up here writing, just as a point of comparison. No one would argue with the statement that we should expect students to write in every class, right? Well, writing instruction is certainly not the norm in terms of our curriculum, outside of the amazing work that I see Tim McCormack's here, outside of the amazing work that our writing program does and is helping faculty develop. But we expect students to do it, even if we don't necessarily teach them to do it. We don't really expect students to do quantitative reasoning, at least not in the same kind of systematic way that we expect students to write, outside of the STEM fields, at least. And quantitative reasoning, as I'm sure everyone here is aware, it's a crucial academic skill. It's different also from quantitative analysis, right? And I'll get to this in a moment, but some of the resistance to building QR into coursework has to do with quantitative analysis as a mode of inquiry that some people either don't use or aren't very comfortable with or don't necessarily believe in. And that's different from quantitative reasoning as a skill that we can and absolutely should be delivering to our students. Just some quick places where we have this in the Gen Ed, right? So the required core has the math and quantitative reasoning component. It's 3 credits. Life and physical sciences has outcomes that are QR specific, and in the flexible core, the scientific world does the same. From a systematic standpoint, we don't see evidence of quantitative reasoning elsewhere in the curriculum, again, outside of those STEM fields. We have 8 majors that require Stats 250 or some kind of research methods course that has an explicit quantitative component. 3 majors at the undergraduate level have an experience like this that's elective, and 14 majors where there isn't this explicit requirement or option. It's not to say that quantitative reasoning doesn't happen in the courses or in the curriculum there, but it's not clear where it happens or how it happens. And the purpose of today is because even where we can fix the curriculum, there are limits to how much quantitative reasoning we can build into the curriculum we offer. There are only so many courses that we can create and try to require. Where it comes to the general education curriculum, we're limited by pathways in terms of what kinds of courses we can develop. And we also know that skills without the content and the context that accompany them are not very useful for our students. That students learn these skills better when they're learning them in the context of the content that matters to the programs that they're studying. Like our expectations for writing, we should expect that in every course or nearly every course, students are engaging with some kind of quantitative reasoning content, much in the same way that we expect them to engage in other kinds of reasoning, other kinds of critical thinking. But this also means that we have to ask our students to do this in every course. And that means we have to be comfortable asking. QR is an important skill for understanding, for comprehension, and integrating this kind of skill into the content that we teach. We know from several studies enhances our students' ability to understand that content. And I'll go through that when I go through an example of how you can build a quantitative reasoning assignment through something that may not be explicitly, or at least on its face, something that's related to quantitative reasoning. When we integrate quantitative reasoning into our content, we're talking about doing this in an explicit way. We're talking about doing it through classroom instruction. We're talking about doing it through readings and activities outside of class that highlight the development of this skill and assessing students' work as they use this skill to engage with the material that we're using to teach our courses. When we look at least some of the resistance that has existed to doing this kind of integration, and here the title of this slide is "I don't do regressions," and I titled the slide "I don't do regressions" because I have heard that statement said a number of times to me, just in the context of developing and teaching research-oriented courses. Even in a social science field where quantitative research is certainly well practiced, right? If not necessarily a norm of research. I don't do regression, so I don't teach that kind of stuff. I don't teach numbers. I don't trust statistical analyses, or I don't understand them. I don't believe in them. I'm not good with numbers is something I put up there. It's not uncommon to have students say that to me in the content. I'm not good with numbers. I'm not good with math. I was never good at math. That quantitative reasoning is a lot more important than just the mathematical skills that underlie it. Right? It's, quantitative reasoning is not regressions, right? It's not quantitative analysis. So the quantitative analysis is a part, and admittedly a more advanced part of how quantitative reasoning skills should be introduced to our students, how it's delivered to our students. Most people here will be familiar with definitions of these terms, but I'll cover them anyway. Quantitative literacy, which is a related skill, it's the ability to read and understand numerical information. When we present students with a table of information, with figures, right? Can students read? Can they understand the information that's presented to them? When they see numbers in a passage, right? Do they know what those numbers are communicating? Quantitative reasoning is the ability to produce, to manipulate, and to make decisions using numerical information. So quantitative reasoning goes a step beyond the understanding of that information and then gets into how that information is used in making decisions and drawing conclusions. Oftentimes where quantitative reasoning exists in our curriculum today and in our teaching, it tends to be implicit. Many of our courses, even a variety of disciplines, including the humanities and most of the social sciences, many course readings, many of the things that we ask students to engage with will include tables or figures. There'll be numeric information in texts, right? So information on amounts, comparisons, percentages, relative numbers. A couple of questions to ask here is, how often do we assume that students automatically understand that material? I think oftentimes we just assume, or we take for given that because something is in the text, that students will know how to engage with that. At least we implicitly do this because we don't cover how to understand that information in context. And how often do we ask students to use this information in assignments and exams? And that tends to be then the opposite, right? We just expect students will know what to do with this stuff when it shows up in course readings, but then we never actually ask students to use that information properly, right, in the context of doing assignments or doing exams. That may not be true of everyone or most of you who are here. I've seen this through looking at lots of examples of student work over time where students are writing what are, in many cases, very well-written papers that do not engage with numeric information at all. They don't use anything numeric, don't use data in terms of helping them support the conclusions that they draw in that work. So even where we think that students should be able to do this already, we seem to rarely ask them to engage it. And again, the point of me introducing this today, again, different from the morning session, is to make this more of a pedagogical tool. So given that we want to introduce quantitative reasoning skills to our students, given that developing curriculum around that is, number one, time consuming, so it'll take time to develop the curriculum around this, but also we can't just simply require a bunch of QR related courses, and I don't know if that would be the best way to do it anyway. The purpose of this is to empower you all with some tools of how to introduce QR into the courses that you already teach. Doing this, right, at least on a basic way, is simply emphasizing the quantitative information that's already part of the content that you assign. Here I give a quick example from the rise and fall of the American Whig Party, which is a lovely written history of the American Whig Party and its rise in the early 1830s and its demise in the 1850s. And what the author Michael Holt does, and these are just some screenshots from it, he weaves numeric information throughout the narrative that he develops about the Whig Party and its development. And he really does an excellent job in what is a well-written history of marshaling numeric information to make certain points. Not that you have to read through all of this, but the point of using the numerical information here, which are here it's just tables or discussion of election returns. The numeric information here makes the point that support for the Whig Party as a partisan identity was incoherent in southern states in the 1830s, which was relevant to the story that he develops, the narrative that he builds around the growth of the Whig Party, right, in its early formation. And here it's just a quick example of me taking something that is very squarely written in the humanities, right? This is very much this very much represents the research methods of history as a discipline, but it uses numeric information to draw and support certain conclusions. And it would be very easy to use material like this to simply highlight to students, or at least to explicitly ask students to engage with information like this in understanding the conclusion that Holt is drawing. Beyond these kinds of basic tools, like simply highlighting the quantitative information where it exists, there are some best practices around building quantitative reasoning skills in your courses, regardless of what you teach. One of those best practices is to explicitly introduce a quantitative reasoning skill embedded in the content of the course. That is, you don't want to throw the entire field of quantitative reasoning at a student, but you want to pick specific skills that you help students develop, and you want them to understand that skill in the context of what they're learning in the course. The first part of that is developing what is a quantitative reasoning lesson. Right? A quantitative reasoning lesson will take the skill that you want the student to develop, and it will introduce that skill in the context of the course material. It starts with identifying the learning outcome or outcomes that you want students to gain through this exercise. If it's needed or desired, teaching the underlying math skills with that quantitative reasoning skill. Right? So this could be a refresher of arithmetic or basic algebra, comparisons of numbers, right? Whatever the mathematical skill that the students need to engage in the quantitative reasoning. You want to demonstrate that QR skill in the context of the course. And if you can, provide lots of examples of how the student can use that skill to understand the material. A good QR lesson will let students also practice the skill in an assignment moving forward. And then you'd want to assess how well that lesson and assignment work. That is, are you presenting the quantitative reasoning skill in a way that students can learn the skill and apply the skill to future course content? Looking at some of the steps there in developing the quantitative reasoning lesson, and I'll show an example in a moment. When we develop learning outcomes for a quantitative reasoning lesson, we can think of those outcomes in fitting in certain buckets. One of those buckets is in knowledge and conceptual understanding. That is, what are the things that students need to know in order to properly develop this skill? This could be an understanding of relative numbers. It could be comparing, right, different numbers, different sizes. It could be something as advanced as being able to understand graphical representations of data. But this is where you will very clearly state what is the knowledge that a student needs in order to develop the quantitative reasoning skill that we want to focus on. The second bucket is thinking and other skills, right? So once students have a conceptual understanding. How do they use the information provided to do the task that we're asking them to do? The last bucket are what we call attitudes, values, dispositions, and habits of mind. Basically a way of saying, once students use the skill, once they develop the skill, how do they then apply that skill in similar contexts later on? A good QR lesson will also present the mathematical skills that students need to perform the task. And even if this is just a basic refresher of things that they should have learned elsewhere, and it'll teach the content of the course using the skill and provide examples. And that now leads me to an example. Stop the share here, share something else. This is an example that came out of the American presidency course I teach. For those of you that don't know anything about how research is typically done on the presidency, a lot of this work, even in political science, is qualitative work. A lot of work revolves around case study. It may or may not include numeric information. A lot of the work is in developing theory, and theory that's supported through case studies of individual presidencies. Some of the work is quantitative, right, in terms of how the research is done. And I'm bringing this up to demonstrate that the American presidency is a topic that doesn't always easily lend itself to the kinds of quantitative reasoning that we think that we more instinctually think of in terms of research. An American presidency research can be quantitative, but one of the issues with that is we just haven't had a lot of presidents. Right? So unless you do some kind of very fine-grained analysis of kind of individual months or years, there's not a lot of data to do good quantitative analyses, which is why the field itself has lent itself more towards case studies and qualitative work. And what I did with how I teach the presidency was I took a topic that again lends itself to good verbal discussion, and I found ways of presenting the ideas in a quantitative way to help students understand what the topic actually, what the importance of the topic. And the topic here is veto bargaining. And again, I'll give a quick introduction to what it is. Vetoes are rare in American politics. What is very common is what's called a veto threat. So presidents, typically not directly, typically through surrogates and certainly in private, will communicate dissatisfaction with policy as it winds its way through Congress. More often than not, presidents are doing this not because they want to veto things, but because they're trying to get Congress to make concessions to adapting policy that is more in line with the president's preferences. And what the work on veto bargaining will argue is that veto threats, when the president makes them, are really only effective if they're credible. So the question then becomes, how do we understand the credibility of the veto threat? There are different ways of doing this. One of the ways that I introduced to students after developing these assignments is through simple graphical analysis. And really it came down to being able to plot things on a number line and make comparisons about how far away things were from one another. When it came to the learning goals of this lesson, the first learning goal, so the knowledge and conceptual understanding that you'll see there, students will draw a unidimensional continuum, a line, and correctly graph data points on this continuum, calculate the distances between them. The math there is fairly basic arithmetic, and not something that I'd have to go into detail teaching students, but I also wanted to be explicit to students what they were being asked to do. Draw a number line, correctly place points on it, be able to calculate the distances between them. For the thinking and other skills, students will compare distances between sets of data points, use those calculations to explain decisions made by different actors. The actors here typically would be the president, Congress, comparing that to some kind of status quo for the policy. For the attitudes, values, dispositions, and habits of mind, it's developing the habit of using graphical representations of data to draw conclusions. Right? And again, by very explicitly listing these for students, it's my way of signaling to them, this is what I'm hoping that you'll do. I'm hoping that you'll understand how to graphically represent data that you're given, and to draw conclusions using that. And one way that gets tested is then down the line, asking students to apply that skill in a different context. And I'm not going to go through the full lesson here, but this is a handout that I would give in class. Really, the important parts here are kind of the rules for how to do this, and then again, starting with some general scenarios that walk students through how to use a number line to understand, when a veto threat is credible and when it's not credible. And the way that this then becomes tied to understanding the actual course content is with the real life examples that I ask students to engage with. One of those is a veto threat from the Obama era. You can see here, right? So this is a veto threat for what was I'm trying to see which spending is for the defense spending bill. And what it does is what was nice about the example is there's an associated article that I give students that tells them how much money President Obama preferred to spend, the amount of money that Congress expressed in its preference for the bill that it passed, and really a simple comparison showing students why the veto threat in this case wasn't a credible. Because while the president wanted a different level of spending, here it's because what Congress was proposing was better for the president than what the original policy was. So if no budget bill gets passed, you typically get a continuing resolution, which is so the same amount of, it's either the same amount of spending or some fixed increase, some fixed percentage increase in what the spending will be. In this case, this is what spending would have been. This is what Congress proposed. This is what President Obama wanted. Congress's proposal was better than what the status quo was. And for the students, hearing that and talking about it is a lot different than seeing it presented in a graphical way. In some ways, it reduces a lot of the complexity out of how veto bargaining works. It reduces the complexity of a lot of the negotiation that takes place between the White House and Congress. But it also presents in a simple way how veto bargaining works as a concept, as an idea. That if the president threatens a veto, but Congress is really offering something that's just a little bit better than the status quo, then the president's veto threat probably isn't a credible one. And this was a case where, again, using historical examples like this, not that it's that far back, but we know that this bill did not get vetoed, so the president ultimately wound up accepting what Congress passed. And these kinds of graphical representations for students gave them a way to understand the concept while also building the skill of representing ideas or data in a graphical space. Let's see.
So, can I ask a question, Andrew?
Yeah. Mm-hmm.
So what I find interesting and a little bit scary for me, if I were in your class at my advanced age, I hope they're in a better place. But I can interpret data, but asking me to actually present it when I'm not I was a math major, but I'm not a mathematician. I'm not a statistician. How do you get them over that fear themselves? And maybe some of the faculty members who you articulated earlier have some fears around this. The lesson and the handout is there. This is hopefully you all see now the associated assignment to this. So after we go over the lesson, I give students the assignment. They go home, they do it, they come back the next class and we talk about it. And the assignment here, and I'm just going to scroll down, I give them, in this case, I gave them an article from The Hill. And the assignment here draws on something very close to the example that they had in class, So instead of a defense budget bill, this is a funding bill for HUD, And the article highlights different amounts of spending, So that even in Carol, believe me, I've heard lots of students say, I don't like numbers. I can't do this. The numbers are presented in a way that I think nearly every student I've had who've done this. There's always been there have always a handful that I spend a little more time with to help walk them through it. But it's also the way that you know the questions are asked to get them to understand what the numbers mean, right? So, right, the first question: assuming the House and the Senate have the same preferred level of spending, how much would Congress prefer to spend on the bill? And really, I mean, if you all you had to do is read through the article, right? So President Obama is threatening to veto a $55 billion Republican funding bill. It's right, you know, it's right. And if you read down a little more, you get a little more specific, right? So it's 55.3 billion. But nearly all students, right, picked up on, right? So this is, this is the funding bill. Right? So Congress wants to spend 55.3 billion. Yeah, the next question there is how much would President Obama prefer to spend? And again, so you just read through the article a little bit. The bill provides $1.5 billion more than current spending level, but 9.7 billion less than President Obama's request. It's, again, I've had nearly every student who did this picked up on the fact that they had to add 9.7 to 55.3 to come up with President Obama's preferred level of spending. And in going through each of the questions, right? So if the bill is not passed, right, what is the level of funding? They answer the first three questions. They actually get, again, if they follow the lesson, they get the president's position, they have Congress's position, and they have the status quo, which are the three things that they need to kind of plot points on this number line. Then I asked them, right, how far is President Obama from this to how far is Congress? They calculate the distances, and then they have all of the information they need to draw a proper conclusion, which is that in this case, the veto threat isn't credible, right? Because the Congress's preferred level of spending is actually closer to what President Obama wants than if President Obama vetoed the bill and they were stuck with the status quo. And it's I will say, because I'd given this assignment, I developed this probably back in 2016. In the years that I taught the presidency at least once a year, right, since then until I started doing this. It is amazing how it just dawns on the students that, the threat wasn't credible because the president actually got something better than he would have had. And they understand it in a way that, let's see if I have the, is the assignment lost. Oh, here's the assessment instrument. Yeah. So that then when I give them this later on, and sometimes this assessment instrument, sometimes I made this part of an exam. Same deal, just without all of the hand holding. It's here's what happened with the state children's health insurance program. And I do this through a policy making context, but we talk about this in class. Right? When I teach the presidency as another example of presidential congressional relations, they read through the article and without all the hand holding, I'm going to say that probably 90% of the students, right, when asked to understand what happened in this situation, even if they don't do it exactly the way that they do it in the assignment, they sketch out a number line, right? And they draw points. Maybe the points aren't perfectly spaced, but they put they plot President Bush's preferred position there, and they put the House bill and the Senate bill, and they figure out that had the Democrat controlled Senate at the time, had they been maybe a little more conservative with the increase in spending that they proposed, that maybe President Bush wouldn't have vetoed the bill. With S-chip, my punchline is to not to have worried about the children, because that was one of the first bills that President Obama signed into law when he took office, was the reauthorization of S-chip. But this was a bill that once it passed the Democrat-controlled Congress, President Bush vetoed, right, that extension. And when the students kind of put it out there on the number line, it becomes very clear to understand why. It was because when we looked at what President Bush said he wanted, and we looked at how much more spending Congress was trying to authorize. Again, there's a lot of complexity that went into these S-chip negotiations.
But for an undergraduate class, right, something like this both gets students to understand what veto bargaining is, and they do it in a way that they develop the skill of using numbers to figure out why that's the case. And this is the point in time where I'm going to more or less stop talking, because I've gone through really what I wanted to cover, and I'll put up the resources part of this afterwards. But as you know, what I said that part of this was, at least in my description of the session, was to hear from some of you about the kinds of assignments that you give, maybe as a way of workshopping, as a way of talking about how in the classes you teach, you can think about building in these kinds of quantitative reasoning skills, right? Even if it's one skill in one assignment, right, in one lesson, how can we introduce students to numeric information? How can we ask them to use that information, right, to develop the skill of drawing conclusions using it, right, and in a way that they can then carry that forward, and really engage in use of that skill in a way that puts them in much better shape to engage with this when they leave John Jay, right? Whether it's for careers or further education. And we can also talk about, we can also get critiques of this from some of my STEM colleagues that I see here. Mm-hmm. Am I teaching it right?
Well, while people are thinking about your answer, for me, it's music to my ears, because a lot of our students go into social justice issues fields, and what I want in the policy work that I do is to get people to make decisions based on data and not emotions. And so learning this skill, I think, is going to be helpful, really not just helpful, critical to where I hope the world is going, and that people make data informed decisions. There's still a component of, because I looked at your chart, and I would love to have a side conversation with you later about, because I don't think that data fully informs how the process happened, but it gives them a context of thinking about it in a different way. So I'm liking this skill that you're trying to build with our students.
It also, I mean, it oversimplifies the process of veto bargaining, but it makes it come alive for students in a way that, having taught this material for a decade before I did this, it never worked before. And having just looking at the numbers, just for whatever reason, it clicked with a lot of students. And it was for me, it was a way of seeing that we could do a lot more of this if we're explicit about again how we try to teach things to students. And Tim put in the chat, right, there's a lot of pedagogical stuff happening here, and I'm not going to claim to be an expert at pedagogy, but with quantitative reasoning, I've done a lot of work on how to teach it. And I'm again, today is about sharing that. I know I've got a lot of experts here already, so hopefully what I'm also doing is spreading the word that you can go and spread to others. So, anyone have an assignment they want to talk through, or anyone want to critique the process? Tell me how, or you know what? I mean, given the folks in this room right now, think of this as maybe think of this as a model of how we could design workshops around QR pedagogy. Does it work? Do you think it works? Is this something that I could go and talk about with Gina and try to roll out? What are the where do you see the pitfalls here? I mean, is this something that other faculty would want to engage with?
Can I throw something out as an example of why I think that the skill would be really helpful for our students? So when Sean Donovan was Secretary of HUD, he was all on our side with, getting regs in place to deal with the next level of ban the box and giving opportunities for people who were formerly incarcerated. We had all these regs we wanted him to push. When he got to OMB, and he had to look at it from a quantitative perspective and the likelihood of getting it done within the short window we had, he changed positions. much to our chagrin, we were like, you were with us, dude. Why'd you just switch sides and now you're no longer with us? But it is an example. I think that it's a good way to teach skills about how when you're looking at it from a different perspective, you reach a different conclusion and how all these things intersect. So I am, again, fascinated that and relieved that we're developing this muscle for our students.
Tim,
Andrew, I have a potential example of an assignment if you want to hear me out.
sure. Tim, did you want to jump in first? Because I know your hand shot up.
No, I would never jump in front of David.
David, go ahead.
Well, I know that that's not true, by the way, but I'll go anyway. Thank you. So this is an assignment that would require students to determine whether a number is material and have to use other quantitative measures to assess the meaning and importance of the number, including its reliability. Here is the number. The number is an estimate of $47 billion in 2022 lost to organized retail crime, right? The number is based on surveys and further expert opinions. Is that number material? How do we determine whether that's something to worry about or not? Now, the hint, of course, is in just to simplify it for everyone, because I know it sounds more mysterious than maybe it should, is that the inventory shrinkage rate, the loss from inventory where they don't know where it went, right? Maybe theft, internal, external, is about $95 billion. And that number, as a percentage of sales, has remained between 1.2 and 1.6% over the past several years. So we see that the overall gross number of inventory loss hasn't changed, but we got now an allegedly larger chunk of it coming from organized retail crime, right? Is that something to worry about? Is it not something to worry about? And what I like about this kind of assignment is that it asks students to do research about other numbers. And it doesn't necessarily have a right or wrong answer. It's all about the reasoning, the quantitative reasoning. It's not about, yes, it is material. No, it's not material. It's how did you determine that? I found that quite intriguing on my part. And I haven't come up with an answer on it, but it did come to my mind yesterday. Thank you.
Well, it's I think part of the challenge of doing this with students is just getting them comfortable with numbers at all. And David, I love the idea of just anything that we could do to engage students to just care about what the numbers are telling us. Even if there is no right or wrong answer to it, right? Just seeing and I think especially letting the students see for themselves how they think using the numbers. I think it's anything to increase our students' comfort with quantitative stuff is definitely helpful.
Yeah, and if I may, don't think Carol was able. I think my sentences may have been lost over the internet. Just summarize, Carol. What I was talking about was a figure of a gross figure of an estimate of organized retail crime loss. Smash and grab, gangs going into stores and organized grand shoplifting. Figure was given, right? But the figure doesn't really jive with the overall figures year over year of inventory losses. I mean, in other words, is it a sensational set of anecdotes, or is it a real trend? And that's sort of where I was trying to go with that example. Thank you. Is that enough information, Karen? Thank you. Yep, good. Sorry about that.
Is that Valerie put in the chat, right? And I love that getting students to talk about numbers or their reasoning process using numbers in plain language. And it was just created, so it hasn't been offered yet. But Valerie created a great class that went through UCAS last year, right? is it titled stories and numbers? Is that the title, or is it numbers? You're muted, Valerie.
Yes, that's what it's called. I'm hoping it'll run in spring.
Yeah. And I loved seeing the course proposal, because it does just this, right? It takes a context, it takes a topic, a content that is not automatically quantitative, and it very wonderfully integrates these skills throughout the syllabus. I mean, Valerie does this through, it's in the entire syllabus, right? So it's more than just the example of doing this in one lesson. The entire course is built around this, and it's fantastic. Tim?
Yeah, just coming off of what David said, and linking it up to what you said earlier, Andrew, you know, if students are afraid of numbers, and I guess I can include Carol and myself, if we are afraid of numbers, right, we can be.
I have to give you a qualification. I was a math major, Tim, so
Okay.
I'm not
Okay.
afraid of numbers. I just don't know that I could graph things out.
Right. Afraid of doing things with numbers. That means we can be fooled by numbers, right? And so to David's assignment there, right? So when you hear the number $47 billion in losses, you instantly think that's material. That's important. 47 billion, that's a huge number, right? But it's about what is that number in relation to what it normally is, or what is that number in relation to other ways that money is lost in business, or through fraud, or through whatever, right? So when we instantly, you know, want to avoid numbers, we can be fooled by them. So I think that's like another reason why this is so important, right? You can be tricked, you can be bamboozled if you avoid numbers. And the other thing I wanted to say, going back to your earlier part, was we talk a lot about that students need to have evidence for their arguments. If you leave out numbers out of that, like if your evidence doesn't include any numbers, that's a big loss. Like that's losing half of your possible evidence. And I'm just throwing out a number, half, like who knows? But you know, that should not be avoided. That should be, you know, one of the primary ways we give evidence. And so an assignment I actually do in my Valerie actually knows this assignment pretty well, in my English 201, which is a writing course, where we ask the students to do projects in 3 different disciplines. My middle project for years now, probably for more than a decade, has been this partly quantitative, partly qualitative project, where I ask them to count the number of languages they encounter in their daily life in 24 hours. So they count the number of languages, and they count the duration of the languages. So I get 2 number data points. And then when they come in, you know, but I also ask them to do field notes. I also ask them to collect some other things that aren't number oriented. And then they come into class on the day that it's due, and they have all this number data, and we do math right up on the board. What does it mean? You know, how, like collectively, how many languages did we encounter? What % of the time was English? And there's literally like 6 or 7 students can't do very much at all with the numbers, but the other students will teach them, you know, how to do a percentage, or how to do an average, or what a mean is, right there on the board. And all of that gets then put into their social science report, where they're required to include a chart of some kind using the data that they had collected. And that's part of their evidence for their report. There is a qualitative section too, so it's a mixed methods kind of study, and this is at a very basic level, but still I'm astonished by how, you know, how much data they can create, or to use your word, produce, just with this small, crazy assignment that I'm asking them to do, to count languages. They can expand on those small numbers to make much bigger numbers and make much bigger claims, using numbers as evidence. And that's in a writing course. So I think there's definitely room for more of this, and the students will do it if you give them the opportunity.
Yeah, Tim, one of the great things that I heard in that assignment that you give too is it contextualizes math skills that students already have. They just didn't know how those skills applied in a different context. And some of you have heard this story before that I give, right? So whenever I teach the intro to research course in political science, I get to a point where we do regression. And I throw up a table of regression output, and students, look at this is terrible, just numbers that make no sense. And I go into the lesson, right? And I throw up, a set of axes on the board, I draw a line, and I ask the class, right, what's the equation of a line? And sure as hell, out of a class of 36 students, at least 35 of them yell out, y equals mx plus b. Okay, so we write that on the board, y equals mx plus b. And I'm like, all right, what's m? M is the slope. Okay, what's a slope? It's rise over run. Everyone memorized rise over run. Right? I don't care if you did math 50 years ago or 5 minutes ago. Everyone comes at you come in high school, rise over run. All right, well, what does that mean? And they go, well, it's the change in y over the change in x. And then you start to see that dawning recognition among some of them. And then you just take it a little further, right? These numbers in that regression table, those are slopes, right? That tells you how this one thing changes when this other thing changes by 1 unit, whatever that is. And they now connected something that they have used so much at some point in the past that they could just spit it out. They don't even know why they're spitting it out. It's almost like a gut instinct at that point, right? Rise over run. And they use that. You can almost see the synapses connecting and firing off, making this connection in their brain that that helps me understand this other thing that I'm looking at. And once they do that, you can get them to understand damn near any quantitative. I don't care what kind of statistical analysis is being presented. If it's based even loosely on ordinary least squares regression, they get what's going on. Even if their interpretation of the number isn't exact, they understand what the numbers are trying to communicate to them. And it was because it was tied back to something that was drilled into them at some point in the past. And that's I think another important pedagogical tool is making them realize that they already have these skills. Even when they say, I don't like numbers, I'm not good at numbers. I don't know numbers, but you know enough to be able to develop that skill. Wynn, I know you wanted to contribute.
Thanks. Yeah. I mean, I think as far as moving forward, one thing that will really help us is if the faculty are able to generate sort of a set of QR goals like we've been doing with the writing rubric project this past couple of years, so that sharing assignments and strategies can start to fit into or connect to a tool that can be used across disciplines. That's sort of crucial, not just for the dialogue here, but also for the students to understand how skills they develop in one class transfer to another. I think that's, that is our goal, and it's really important that we achieve that if we want to look more closely at the curriculum. And the other thing I wanted to say was, there's a lot of, I mean, you all have heard me say all these things before, I know, but I'm going to say them again. There's a lot of talk and concern about students' prerequisite knowledge and skills, even more so since the past couple of years of the pandemic, right? So thinking more intensively about what we're offering both incoming first years and transfers in terms of academic bridges that complement the amazing work that we do on the social transition to college and to John Jay. I I think would also benefit students. We have some examples of pilot projects, you know, more recently with the MBK work and back in the day with the OSS students, and, you know, thinking about how every student could have experiences like that, I think would really help prepare everybody for a strong start. And I think we have to feel, the last thing I'll say is like being confident about moving out of using the pathways learning outcomes as the tool to understand how learning works in gen ed to a couple simpler tools that can be used across all the categories of pathways. I look forward to that.
Amen. Heath?
I just always like to follow after Wynn because I always agree with everything she says. But first of all, this has been very helpful. And I feel like every time we have these discussions, it's getting clearer and clearer, and we're getting to more concrete examples, and it's just getting better and better. That's the first thing. And the second thing, to Wynn's point about tools, one is for the professors to teach, but I do think this also has to be brought into all of the assessment process. You know, it's something we've tried to start to pilot in LPS, tracking developmentally where they are with quantitative reasoning in first year, and then as they go through the core classes into upper years. And I think if that kind of a tool was standardized, ours needs a lot of work. I'm not saying we have that model tool yet, but it's something we really, I think we need to take more into the discussion there with assessment as well.
Agreed.
And that's it.
We're just about at time. Any final comments? All right. I'm gonna thank all of you for coming today, for listening to me talk about this stuff. As everyone here knows, right, this is a passion of mine, right? I really care about giving our students the ability to engage with quantitative reasoning, because to me it is so important to helping them be successful when they leave here, regardless of what they do. I know all of you have been engaged in this work, and I thank you for it. Again, for any reflection that you do of the stuff that we talked about today, if you have any ideas on how we can present this information to faculty better, how we can present this information to students, right? Any ideas you have about developing these tools, so that we can develop not just a strong QR curriculum, but really strong QR pedagogy. I am open to hearing everything. I'm open to working with all of you as you develop this stuff for yourselves, for your own courses, or as you engage with your colleagues about it. I said it in the morning session, I'm happy to show up wherever, whenever, to talk about this stuff, really to talk about anything. I talk a lot anyway. So just point me in a direction and tell me to talk about things, and I'm happy to do it. I'm also happy to listen, and I thank all of you for sharing what you've shared today. It's very valuable stuff. I am done. So
Thanks a million.